third parties of confidence of Europe, I'm very pleased to introduce the leading member of the leading authority here in Europe for the visible security seal. Now, the C is a member of our organization, but it's an iconic member because it's the member that launched the AGCVC association in 2016. So we have Gilles Barret, who's the director of operations, who's Jean-Louis Varol, and we're going to launch straight into the heart of the subject, and we're going to ask Gilles, what is the CEV? Remind us what it is, what is the description, and why it's fantastic. It is indeed fantastic. You're absolutely right. Hello to everyone. Now, not everybody knows what the visible electronic seal is. Everybody knows what this is. This is a QR code or whatever you want to call it, or a matrix code, whatever. So when you see that, you say, okay, well, we know what that is. We know it's a 2D code. Well, what is a 2D code? It's a box, and if you don't open the box, you don't know what's in it. So the specification of the visible electronic seal or code is anybody who flashes this QR code with a dedicated application will be able to verify whether the data inside the code are correctly signed electronically. So the dedicated application that you're going to download, I'll talk to you the elements later, will allow you to verify that the signatures are correct, and will show you the data that is signed electronically in the visible electronic code. And so it respects the privacy laws in application. Now, basically, do you want me to continue, or do you want to pose questions? I'd be happy to pose questions, but I think what we need to retain now is that we have data that are electronically signed, and so I have a question to ask you, which is basically, it just looks like the NTS's 2D doc. You're absolutely right. No secret there. From the 2D doc, which was a sort of code created by NTS for the French administration. Notably, it was created for requests for passports originally, and so this is the basis of the current visible electronic code or QR code that or seal, and at the FNTC, we just propose to normalize those specifications of the NTS, and in doing so, we thought about it for a while, and we realized we found a process that was totally new that we decided normalize as AFNOR and then ISO. So we have an AFNOR standard and two ISO standards for this code. But the original idea was actually what we just called the 2D doc, which was a sort of a private initiative, but why did you have to do several steps in terms of the normalization compared to the 2D doc? Because we could have continued to work with the 2D doc instead of I think what's interesting, Gilles, is that in terms of the private applications, we had to sort of take charge of we had to update the reading applications. You're absolutely right. One of the key points is one of the things that we had developed was an application. This was a universal and authentic reader in multiple languages that was able to decode a normalized ISO code It's an ISO certified code without necessarily updating the application. Before, there were 3 service providers that were developing an application that had to be updated each time there was a new usage case, which meant that it had to be re-downloaded by those who used it. Now we have a single tool which can be downloaded by everybody free of charge, and that will allow, when you have a new visible electronic code, you can read it with having to update the application itself. So it's what we call a manifest. So the reader says, oh, it's the first time I see this code. I'm going to look at the coding grid. I put it on my smartphone, and every time I have this same coding, it's already on my phone. And so the next time you read it, you don't need to re-download. So each time you read one of these codes, you can see that it's been properly authenticated and signed electronically. And this application was developed by the teams of Jean-Louis Reval. And I'm going to ask him, before we move on to the usage cases, because that's what interests us, is the use cases and also its role in cybersecurity. But first I wanted to say, what are the other tools that were developed on the basis of the reading of the CEV, the electronic visible electronic code. Now, once this CEV had been, what was interesting is that is to develop an ecosystem around this visible electronic code for multiple applications. As you understand, the CEV, as it's defined today, is defined in the norms, is rather a generic kind of tool that can be used in lots of different usages, in various different usage cases. Because originally it was to secure documents, but why not use it also for access control, for ID cards, for doing a certain number of things, maybe even tickets to go to a sports event, etc. So the idea was to develop an ecosystem, and the first part of that ecosystem would be the universal reader, which would help you to connect and read every type of existing use case. And today, the reader allows you to read all the codes, all different formats, whether it's data matrix, QR code, Aztec, all the different standards. It will also be able to read all the formats of data defined by the ISO certification rules, and including also formats added after the standards, including photos, a photo of a person, or anything we want. A photograph of a mushroom, why not? We could use it even, which could be it'd be interesting to add into the CEV a photo. So to have a photo, you have to be able to have a system capable of recognizing the photo, which means you have to have a camera. If you want to do access control, you have to have a connected reader, turnstile gates, etc. So this whole ecosystem had to be developed. Now we have a universal reader, and we also have a second, less standardized reader called the BioSide reader, which allows you to do biometric readings. So this is dedicated more to identification. This is what was developed today so far, and yes, Jean-Louis, photos and biometrics. This is something that's very much under the control of the current privacy laws, the GRDP, and protection of private life. Yesterday's roundtable, the people talked about the fact that we can't just do anything. So how can you protect privacy and also get approval from the CNIL? Well, yes, we've been good friends of the CNIL. We're the inventors of the matching card, which was something already that was accepted by the CNIL. So in the same spirit, we developed this code. This is a code that has all the information within it. So at no moment do you need to connect to a database to create this code, including the photo or the biometrics. Everything is included in the code. So the CNIL accepts this this approach. The photo has one particularity, maybe a little bit humoristic for those who understand the world of biometrics. Since the photo is relatively compressed, the distance between the eyes is less than 60 pixels. So you consider that, and the states consider that it's no longer biometrics, therefore it is acceptable. So on that part, do you have a use case that might be interesting on like facial recognition with a CEV? I think there is a case now. Yeah, there exists several. I'll give you the latest one. The latest one was put into service about 2 days ago. And in fact, it's an application that was done for a university in Africa, which consists of having a student card based on a CEV containing all the biometrics, in other words, the digital fingerprint, the face, in order to resolve different problems. The face is used to manage access, and the vital part is for payments, which means the student card will be used for all the social services related to the life of the student. The card is used, for example, to access the university canteen, the restaurant, access to the dorm rooms. You know that in Africa there's certain problems about subletting of apartments and things like that. So this CEV will allow checking and verification of the users. And so the CEV will also be used in the second phase of this project to issue secure diplomas, because what's important about the diploma is to make sure that the university that issued it is the right one, make sure it's a real document, a real diploma, and then make sure also that the person who has the diploma is the real owner of the diploma. So the biometrics and allow you to resolve all of these problems. So you don't need a database, you don't need central access to the networks. All of this is under the control of the user. So it's really so when you create the BioSil, there will be a moment when the data will go into a server, but it's not going to stay in the server. And then certain countries believe that you have to have a permanent database, but that's not our case. We don't need anything. So this allows us to function totally autonomously and without even access to the network, because it's one of the big advantages, especially in emerging countries where you don't always have access to the internet. When the reader is connected once to the network, then you will be able to operate completely in a deconnected mode. Now, biometrics, everything is possible without being connected to the internet. Are there any other use cases where you might be able to, for example, pay a bill with recognition of the person paying and the photo? Yes, there was a use case developed for Ivory Coast. Here you see it's a big code. It's a little panel. It's a panel that's put at the entry point of each member of the Chamber of Commerce and Industry of the Ivory Coast, and you just scan it, and that allows you to recognize whether the artisan is the right person, because the photo is inside. You can verify whether the artisan is up to date with their obligations in terms of the regulations. And you can also pay the artisan by you connect to a platform. It's a big platform for mobile payments. So from this QR code, you can pay your bills and you're sure that you're paying the right person. So that's another example. There's other examples that are amusing. And this is why it's interesting to have this sort of generic code, is that people who are interested in this idea continue to give us new ideas. Quite recently, we had, you have cane in Africa, and so we wanted to create we were able to create Oh, okay. They're talking about a sporting event. So, excuse me. It took me a while to understand what he's talking about. Apologies for that. So the idea is we were able with this QR code to create access to the sporting event, and that means it avoids ticket scalping, people reselling tickets. So that's another example. So this way we've identified the artisan. We have authenticated and secured the link that will allow payment to the artisan. And so what type of payments? Is it strictly mobile payments? So it's a digital payment system. But you could imagine also having an instant payment system that would work as well. There is a project, in fact, for the payment of invoices, payment of bills, which is being considered by EDF. It's a local electricity utility, and you can get this bill. You have a QR code that would show you that this is the right invoice from the right entity, and then you can pay it in confidence. This is just a pilot project. It's not up and running yet, but these are things that are important because in Africa, for example, there's a lot of identity theft, but we have a lot of identity theft here as well. And identity theft is one of the big problems because we have what we call document breeders. In other words, these are documents that prove your identity, and most of the fraud occurs through these types of documents. So most of the countries are starting to become aware of these types of things, and one of the first things they've asked is to be able to use all of these justifying documents like the NTS did historically in France to make sure that they're all secured with a CEV, visible electronic code. In Ivory Coast, they're asking now that all of the documents have this CEV code. So birth certificates, certificates of residency, all those sorts of things are being put into production. So it's not just in France that we're putting these CEV codes on the documents. It's not just in France. We also do it elsewhere. Yes, absolutely. That's clear. So now I'm going to ask Gilles, are there any other countries other than France and the Ivory Coast and Senegal that use massively these CEV codes? Yes, absolutely. I just wanted to say that this technology is not just a normalized ISO, a standardized technology with an ISO standard certification, but it's a real sign of a real tool for creating trust and confidence. Because when you see it, you can see right away whether it's a real or a document or a fake. So with this CEV code, you can see. And we look at people, and when these people are issuing documents, whether it's a state or an enterprise or administration, usually there's no problem. But if you have a private individual who wants to commit fraud and sort of create fake documents, then it's important that we act. And this is a very important element in creating an environment of confidence. And today we have members of 8 nations in our federation. So we started obviously with France, Canada, Tunisia. I can't remember the order, but then we have Austria, Germany. We obviously have Ivory Coast, Benin, and we're going to soon have Senegal and other countries as well. I think we have about 13, or at least we will be 13 very quickly. So it's very important that if we're in the Mediterranean area, where there's a lot of variation in the populations from one place to another, here we have now a solution where anybody, any administration, any person can verify documents. So this is something that's very important. So we are working on making sure that we're developing a strong international network, and in theory, in the coming months, we should have countries that know nothing about technology. For example, South Korea. They're adopting this technology. So it's a sign of confidence. He's obviously being ironic. So our need here, our sort of bet our gamble is that the European Union is going to adopt this procedure. And just to illustrate the advantages for the European Union to adopt this technology, let's take the usage case of the CEV that might be on the COVID vaccinations, for example. Each country had developed its own apps, like in France, and had used its own CEV that was not standardized, which meant that when it got to the European level, the European Union was obliged to pay several tens of millions of euros, I don't know the exact amount, to do what they called sort of passageways from one, or gateways from one system to another. Whereas they could have, very simply, in each country, adopted a interoperable and multi-language visible electronic code, and then let's say if you were in Lithuania, you would have a document that could be read just as easily in Lithuanian, in English, in French, in any language, without it costing a fortune. And so it's a real advantage for Europe. And it's important that they're aware that this tool will allow Europeans to be more sure about the documents that they're sharing. And so it's multi-language, and it's operationally, I think it's how many languages? It's all the European languages plus Vietnamese, Korean, Arab, so Japanese very soon. So the CEV in Tunisia, they started very early. They took the first generation from the NTS. There's more than 70 usage cases, and the fact that it's multi-language has simplified things. They're now moving towards the new standard, which means that for their CEV code, now they can create it in Arab and French. And so that's the dimension I really want to highlight. This is this environment of trust, of confidence. And so our goal is to get a certain number of countries to join. And okay, now for cyber security, what is the added value provided by these CEV codes? Well, there's one thing that's very interesting. You all now know the word. In French, it's hameçonnage, but we used to call it, hameçonnage, but it's in English, it's phishing. And on the TV the other day, you could see people with wonderful cars, very fancy cars. They're doing recharging their electronic vehicles, and they were in the Loire region. There was a QR code to identify themselves and make the payment. And then when they wanted to charge, they identified themselves, they made the payment, but then it didn't work. Well, that was because there was what they called kishing. In fact, the fraudsters had put a false QR code with a link that was obviously a fake as well, which sent the money to that send you to a site that looked like the real site, and people felt confident. This is the kind of thing that they do also with false fines that are sent. It says, for example, do you have a thing that looks like it comes from the police, and they say you're going to pay a fine. If you pay it right away, you pay 10%, a certain percent less, and it works like magic. People just pay to these criminals who pretend to be the authorities, and so everybody that is an issuer of a QR code can now secure them with a CEV code. And us, in a few weeks, with the application that we're developing, and it is dedicated to the interoperable CEV codes based on the new standards, we'll be able to read all the QR codes or data matrix codes that are secured or not. If Mr. or Madam Smith flashes the code, most of the time this will be a normal code. We'll tell them, okay, fine, you'll get the message, be careful, this code is not secured. Are you sure that you want to continue? Especially if there's an internet link. And if it's secured, obviously they can make the decision to do that. Now, why is this important? Because today you could think that this is just a simple anecdote, but in the future will not be just a simple anecdote. Why? Because you all know barcodes. You go to the cash register at a store, and for millions of products that you buy with a QR code, and the company GS1, all the on the 1st of January 2027, all products that used to have a barcode are going to have a QS1 QR code with the brand of the product and a link to the internet. But the only problem is that there's no security. So if you're, I got to tell you, if you're a criminal, there's billions of products that go through the cash, through these cash settlement systems in stores. Even if a 1% is hacked by fraudsters, representing billions of dollars. So it's very important that these codes become as secure as possible. We're working on trying to be able to push this application. It's free. It's free of charge. So the idea is to avoid that Mr. and Mrs. Smith have to get victimized by this. Now, there's a lot of people who think that those who get who are victimized, it's because they were not smart. Well, I hate to say it, but we had a senator who was victim of a fraud with a fake RIB banking transfer document. So it can happen to anybody. I mean, if there was a CEV code on it to secure it, it wouldn't have been the problem. So you shouldn't think it's just old people or idiots who get scammed. Anybody can be scammed. So I think it's something it's important at societal level, and that's important at companies like the big national banks and others that are engaged in the notion of corporate societal responsibility, CSR. It's important that they communicate and participate in the financing of our association, which is a 9001 association, which has a very modest budget, and so we would like the people who have a societal responsibility, especially at the French level, participate in this process. Thank you. But before concluding, currently we are discussing the Seren law, as they're called here in France. What can the CEV code add to this notion of age verification, protection of private data? Jean-Louis, what can you tell us about the proposals? Maybe even there's some demonstrators that have already been put out. Yes, indeed. In this context, this is not part of the Seren law because the demonstrator was done in the north of Canada, where we did age verification to access alcohol. Wasn't a problem of pornography or anything like that, but it was just to see if people were old enough to buy alcohol. And so we had a CEV code that allowed the identification of people who were adults and could buy alcohol. So in the same way that this has been planned in other solutions, we can have access to only certain part of the information, for example, in this case, age. So you can, for example, show just the age and nothing else. And so we're able to meet the needs that are expected. Anybody want to ask also about cybersecurity? Yes, there is one function that's very important, thanks to the CEV code, because the CEV code can have a very short lifespan. It can be a sort of token for identification, either for banking needs or for societal life. You all know Vigo. You all know different things like you all know about Fido. There is no proof of identity because there's no strong link between the object and the person. Thanks to the CEV code, you can imagine that the CEV might not necessarily be something that could be included into a QR code, but it could be included in a chip. And because it's a set of data, that's a data set, it could be used as an identification token for a number of transactions. So in this case, it would reinforce cybersecurity because you really are sure of who you are dealing with. So I just want to add that little comment. Thank Jean-Louis. Thank you, Gilles. We're going to maybe leave a little bit of time for questions and answers. And we are all here. Gilles and Jean-Louis are here to talk with you if you have further questions. They have a certain number of use cases and demonstrators that we'd be happy to share with you, but they're going to do that later.
Merci pour cette explication sur l'historique.
Thank you for this explanation and potential of this instrument, both for ID, physical ID document, but also for any electronic supporting document. It opens the way for digital ID, and all the digital ID with the wallets. France envisaged to use electronic with a visible electronic seal, but have you thought about pushing this standard and this solution at European level and the European Commission as a solution for qualified electronic certificates, but also to secure transactions, peer-to-peer transactions between a service provider and a user to provide squishing, because all the solutions are envisaged as a 2D code, including for payment. So were you in a position to talk to DG Connect or DG FISMA for finance? Well, yes, we did look into what's happening in e-wallets. In the first year, the ECV can be seen as an MDoc. So there are certain features that we'll have to upgrade to be fully compatible with what is required. But in terms of object of commitment, which is what the standard that is envisaged for e-wallet, the peer-to-peer, as you call it, is not really secure. So we would provide, if we used SCV as an element of commitment, it would be an extra security. I don't know whether it answered your question. Actually, in the field of e-wallet, I'm no expert, but you have the potential conglomerate. Now, normally the leader is DS plus the Germans, but at the moment we don't have news about what is happening. I'm not sure that we are proactive in that area, and therefore it may be a shame, but if we could have European connections at the right time, that would be great. So if some of you can help us in this field, they are welcome. There was a demonstrator that was done for ANTS that you can test out on the materialization of the driving license, and also something that is interesting and maybe we have forgotten to describe is it allows also to reproduce identically the original document. And then when you scan the CEV, you are going to reproduce the actual driving license. When there is also for the French diploma, so you can see the diploma here, you have a little CEV that is not really visible, but when you flash it, you have the reproduction on your mobile phone. So that's rather interesting, isn't it? The interpreter cannot hear. Oh, here we go. So the latest webinars, there were some qualified certificates with the visible seal. It's not just a demo. The driving license integrates the ECEV. Perfect.